Okay, so in this video, allow me to show you how to find the LCD of two or more fractions. A lot of times when you add or subtract fractions, you need to know the LCD of the fractions together so that you can proceed with adding or subtracting the fractions. And so finding the LCD of the fractions can be easily done if you follow these basic steps right here. So and you can learn those steps as I'm carrying out my examples here. So in the first example, let's say we're trying to find the LCD. Okay, and the two fractions are 4 and 15, and the other fractions is 3 and 20. Okay, so step number 1 would be making the list of all prime factors from each denominator. So here in my fractions, here in my two fractions, here I have two denominators. The first denominator is a 15, and all the prime factors are 3 and 5. In my second denominator, all the prime factors are 2 times 2 times 5. Now you could have written that as 4 times 5, but once again 4 is not a prime factor, so I need to write 20 as a factorization of all the prime factors here. So that's what I need here, 2 times 2 times 5, because each of these numbers, if you notice, they are the prime numbers. Now if you're not sure what prime numbers mean, make sure you look up on the internet or anywhere, any kind of reference to find out what prime numbers mean. But so once again, that's step number 1. You go through each denominator and you find the prime factors in each denominator. And now to find the last step here is to find the LCD. Now to find the LCD, basically just create for yourself a list. Make a list. Now how is the list going to work? Now what's going to go into the list? If you look over to the first denominator, if you look in your first denominator, you're going to bring all prime factors of your first denominator into the list. So here I have 3 and 5. Okay, and of course they are being multiplied together. And now once you have finished bringing all the prime factors of your first denominator into the LCD list, now you're going to start looking over to your second denominator, and now let's start checking. Is 2 already on the list? If not, multiply it in. And then look over to the next one. Is this 2, even though there's already 1 2 on the list, but this 2 is extra, so I need to multiply it in again. So here I multiply one more 2. And if I look over to this next one, this next prime factor, is this 5 already on the list? And yes, it's there, so I can skip that 5. And so here, and when I run out of all, when I run out of all prime factors throughout the two denominators, and here's my complete list of the LCD. And now all I have to do is just really multiply all these little prime factors together. So 3 times 5 times 2 times 2, all that here equals 60. And that is my LCD of the first two fractions, 4 over 15 and 3 over 20. So in the next example, in the second example, and let's try to find the LCD again in example number 2. And here, and of course the title is finding the LCD. Now the two fractions that I have here is going to be 5 over 18, and the second fraction is a 3 over 10. And so once again, step number 1 is to list all prime factors of each denominator. So my first denominator here is an 18. It has the prime factors 2 times 3 times 3. And once again, why not 2 times 9? 9 is not a prime factor, so I need to write 9 as 3 times 3. So here the complete prime factors list of 18 is 2 times 3 times 3. 10 has prime factors 2 and 5. And so now when I finish writing all the prime factors for each of my denominator, to find the LCD, once again, to find the LCD, just simply make a list. Now what's going to be contained in the list? You're going to go through your first denominator and bring all prime factors of your first denominator into the list. So here I have 2 times 3 times 3. And now when I run out of all prime factors in my first denominator, now let's look over to the second denominator. In the first prime factor, is it already on the list? Yes, it is. So I can skip that. So now I'm skipping that 2. I'm looking over to my next prime factor. 5 is 5 already on the list of the LCD? Not yet. So now I need to multiply that 5 into the list. And now do I have any more prime factors to multiply into my LCD? No more. So my final answer to the LCD would be 2 times 3 times 3 times 5. And that would be 90. And so 90 would be my least common denominator. Example number 3. And once again, we are trying to find the LCD. Okay, and the fractions I have would be 1 over 5 and 1 over 4. So, once again, in my step number 1, always I need to write all my prime factors in each of the denominator. So 5 would be equals to 5 times 1 itself. Now, notice 5 itself is a prime number. The denominator itself is a prime number, so the only way I can write it is 5 equals 5 times 1. 4, however, is not a prime number, so I can go ahead and find all the prime factors of 4, and that would be 2 and 2. So now to find my LCD, once again, here's how my list go. The LCD list, first of all, I'm gonna go ahead and throw in all my prime factors of 5. And well, 1 is you don't have to multiply 1 to it because it's always there. So I can just simply put in 5, and because 5 is the only prime factor. And then now when I'm looking over to my second denominator, is 2 already on the list? Not yet. So I'm gonna multiply in that 2. Now, is this 2 already on the list? Even though there's already 1 2 on the list, but this 2 is extra. So I need to also multiply that extra 2 on the list to the list. So now to finalize my LCD would be equals to 5 times 2 times 2. Those prime factors that I put on the list here. Now I just simply multiply them together. So 5 times 2 times 2, and all that here equals to 20. So 20 would be my LCD in example number 3. Example number 4, we're trying to find the LCD again, but this time let's try to turn our focus to those problems where there are more than 2 fractions. So this time let's try something with more than 2 fractions. How about 3 fractions then? So my first fraction will be 11 over 12. My second one is 2 over 15, and my last fraction is a 5 over 18. So once again, step number 1, always we just simply need to find all prime factors in each denominator. So my first denominator, the prime factors would be 3 times 2 times 2. In my second denominator, which is the 15, all prime factors would be 3 times 5. And in my last denominator, which is the 18, all my prime factors would be 2 times 3 times 3. And once again, once you have finished making the list of prime factors in each denominator, now let's try to find the LCD by bringing in a common list. Now, in this list, simply, always, all those prime factors in my first denominator, just go ahead and bring all of those into my list. So 3 times 2 times 2. In my next one, in my next denominator, if you look into the next denominator, is 3 already on the list? Yes, it is. So now I can skip that 3. 5, is it already on the list? 5 is not already on the list. So now I'm going to have to multiply 5 to my existing list. And now, continuing with that list, I'm moving over to my last denominator. And once again, if you look at the first prime factor of the last denominator, if you're looking at the first prime factor of 18, is 2 already on the list? Yes, it is. And as a matter of fact, there are 2 2s in the list. So I do not need to multiply that 2 into the list. Is 3 already on the list? Yes, it is. The 3 is right here, already on the list. So I do not need to multiply that 3. But when you look over to the last 3 right here, this 3 is extra. There's only one 3 in the list, so you need to multiply that extra 3 to the list. And now, is there any more factors? Is there any more prime factors to multiply? No more. And so all we have to do now is just simply multiply all these prime factors, little prime factors together, and that's how we get the LCD. So that would be 2 times 5 is 10, 3 times 100, all together 180 is my final LCD. Example number 5. And once again, let's try to find the LCD of 3 fractions. How about we have 4 over 15, and the second fraction is a 5 over 24, and the last fraction is 7 over 8. Once again, before you can find the LCD, you need to find the prime factors in each of your denominators. So 15 has 3 times 5 as the prime factors. 24 has 3 times 2 times 2 times 2. Now once again, why not 3 times 8? That doesn't work because we need to find off 8 itself is not a prime number. Why not 6 times 4? Because 6 and 4, they are not prime numbers. So we need to write all the prime factors. That's what we want. And then the last denominator, 8 equals to 2 times 2 times 2. And once again, you need to write each denominator as prime factors. And so now, to find the LCD, just simply create for yourself a list. And what goes into the list? Whatever all the prime factors of the first denominator, you're going to bring it into your list. So 3 and 5. So 3 times 5. And now when you're done bringing in all the prime factors of the first denominator, let's look over to the second denominator. 24 has 3 times 2 times 2 times 2. So 3 is the first prime factor of 24. And is 3 already on the list? Yes, 3. Yes, it is. And so you can now skip that 3. If you look over to these 3 2's right here, the 3 2's right here, none of them is already on the list. So now you need to bring in all the 3 2's together. 2 times 2 times 2. So the 3 2's, they have to be there. The 3 2's here need to be multiplied to the list. And now if you look over to the last denominator, the prime factors are the 3 2's right here. 2 times 2 times 2. And the 3 2's here are already on the list. So you don't need to multiply, once again, you don't need to multiply these 3 2's into the list. And then this is it for all the prime factors of your LCD. Now you can just simply multiply all the LCDs together. And so 3 times 5 times 2 times 2 times 2 together, it makes 120. And that is your LCD for the 3 fractions. Now looking into the last example, example number 6. And once again, we want to find the LCD. The first fraction I have is a 1/3. The second one is a 1/5. The last one is a 1/4. And so once again, to find the prime factors in each denominator, 3 equals to just simply itself, 3 times 1, or 3 times 1. 5, once again, 5 itself is a prime number, so you can also write it as 5 times 1. 4, however, is not a prime number, so you can find prime factors of 4, which is 2 times 2. And so now, here's my LCD. Once again, get for myself the list, and the list always contain all prime factors of the first LCD, so 3 goes in it. And then in my second denominator, is 5 already on the list? Not yet, so I multiply it. And then moving over to the last denominator, 2 and 2, are these already on the list? Not yet, so I need to multiply both of the 2's into my list of the LCD. And now finalizing my LCD, 3 times 5 is a 15 times 2 times 2 is 60 altogether. So 60 is my LCD of the 3 fractions together.